The next type of conic section we're going to look at are called hyperbolas. So we've talked about circles, we've talked about ellipses. The next one would be hyperbolas. Hyperbolas are the ones, if you go back to the original beginning of 9.1 video, there's one of the four conics has two cones, and you got to slice through both of the cones to create the conic section. That's the hyperbola. So a hyperbola actually has two branches, as opposed to one circular figure like the ellipses and the circles. So if you ever looked at the way a lamp that's sitting on a stand might look, right? Look to see how the light forms. There's a branch that forms up on the top here, and then there's another branch that forms down the bottom. That light version is what a hyperbola looks like. So there's two branches. Like in this case, one of the branches of the hyperbola would be up on the top here. And then the other branch would be down the bottom here. And there would be two axes in the middle, right? There would be a horizontal axis and a vertical axis. Now this one opens up and down, but I mean, if you took the lamp and turned it sideways, it would open left and right. So hyperbolas can open in more than one direction. This one says the foci are located inside the branches rather than inside of a closed figure. So one focus is up here, the other focus is down there. And in the definition of a hyperbola, you're going to see that the points on the hyperbola are all the same distance from the foci. So it says a hyperbola is a set of points in a plane. The difference of whose distances from two fixed points is constant. So the two fixed points are here and there. And if I take the difference from between the location and that fixed point, they're all the same all the way around. So from here, or on that branch from here. And then, of course, like we saw in the light fixture before, the hyperbolas can open up and down, or they can open left and right. So what's the difference between them, and how do I come up with the equation for them? Well, the difference is in the sign in the middle and in the order in which the equation is written. So remember, for an ellipse, we had an equation, a single equation that looked like this: x squared over a squared plus y squared over b squared equals 1. And of course, with a plus sign in the middle, it doesn't matter whether we put the y squared first or the x squared first. Convention just says we put the x squared first. Well, the difference is, in a hyperbola, there's a subtraction sign. So rather than an addition sign between the two parts, there's a subtraction sign. Which order it's written in tells you which way it opens. So if the x is first, then it's going to open left and right, like that. If the y is first, then it's going to open up and down. And again, if you just have an equation, x squared over a squared, y squared over b squared equals 1, how do you tell whether it's an ellipse or a hyperbola? It's that one sign in the middle that makes all the difference. So how do we graph these things? This one says x squared over 25 minus y squared over 9 equals 1. Make the box. The box, I haven't said anything about a box. Well, here's how we figure out information about the box. First of all, this is not x minus anything or y minus anything, so the center of my box is 0, 0. Right, kind of like what we did when we did the ellipses. We're going to look at the number under the x squared. We get 25. Square root of 25 is 5. So from the center, we're going to go left 5 and right 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Underneath the y squared is a 9. Square root of 9 is 3. So we're going to go up 3. We're going to go down 3. And then we're going to build the corners. So follow across this way. Follow across that way. Down over here. Down over there. Notice I'm making myself a box. Usually we use dashed lines for this. Okay, nice box. The next thing we need are the asymptotes. So the asymptotes are drawn from corner to corner on that box. So from this corner to that corner, through the origin, over that way. All right, and then from top right to bottom left. Next question is, which way does it open? Well, if the x squared is first. Which way did we say x squared first opens? Left and right. So that means that this is one vertex over here. That's another vertex over there. When we draw this in, we're going to draw it in such a way that it follows the asymptotes and the box we just made. So it's going to come down here, touch the vertex, turn around, go that way. And then this one will come around here, touch the vertex, and go that way. So we can find out two more pieces of information about this. One of them is that we can figure out what the foci are. So for this one, it's the reverse. Like in the cases of the ellipses, we subtracted the two numbers in the bottom. In this case, with a different sign, we're going to add the two numbers in the bottom. So c squared equals 25 plus 9. So c squared equals 34. C is square root of 34. So starting at the center, we're going to go square root of 34 units to the left. Now we're square root of 34. It's just a little bit less than 6. So it's over here. So one focus is 0, negative root 34. And then the other focus, if I count 1, 2, 3, 4, 5, 6, is a little bit less than 6. The other focus is, now I swapped these two around. Sorry about that. This should be a negative square root of 34, 0, because I'm going along the x. And then this one is square root of 34, 0. Okay. Notice the foci are inside of those arches. So that's the first thing I can do. I can figure out the foci. The other thing I can do is I can find the equation of the asymptotes. So the equation of the asymptotes in this case is pretty easy because it goes through the origin. So I just have to count. This one goes up 3 and to the right 5. So change in y over change in x. Change in y over change in x. That's the equation of one of the asymptotes. And then the other one goes down 3 to the right 5. So the other one is y equals negative 3/5 x. So those are the equations for the asymptotes. Those are those green lines that are dashed lines that are in there. And those asymptotes guide the hyperbola when I go to construct it. Now, look at the next example. It almost looks like the same example, except this says y squared over 25 minus x squared over 9 is 1. Well, that means that a couple of things. First of all, you notice if I switch the x's and y's, now this one is going to open top and bottom like that. I also switched the way the box goes. In other words, this thing is centered at 0, 0, because it's just x minus nothing and y minus nothing. So y squared is over 25. Square root of 25 is 5. Go up 1, 2, 3, 4, 5. Go down 1, 2, 3, 4, 5. Then underneath the x's is 9. Square root of 9 is 3. So 3 this way, 3 that way. Corners of my box. Draw in the box. All right, next thing we need are the asymptotes. So the asymptotes connect the corners of the box. So let's draw in some asymptotes that connect the corners of the box. Because the center is 0, 0, look, it goes right through the origin this way. And right through the origin that way. I can write the equations for the asymptotes. From the center, it goes 5 units up, 3 units to the right. So slope is change in y over change in x. So change in y over change in x. X-intercept is 0. And not surprisingly, the other asymptote goes down 5, right 3. So y equals negative 5/3 x. Those are my asymptotes. Right, for the foci, 25 plus 9 is 34. So again, just like the last problem, c is going to be the square root of 34. But this time, because it opens up and down, the square root of 34 is going to be in the y direction. So my foci are going to be 0 plus minus root 34. And then the next thing we're going to do is actually draw the hyperbola. So here's the vertex. There's the other vertex. Hyperbola must come down, intersect, up along the other side. Down here, follow that asymptote, comes up, axis, other side. Right, and the square root of 34 is close to 6, so it's going to be a focus over here, focus over there. Right, so those are the two foci for my hyperbola. All right, let's try one more, and then we'll try some that are not centered at the origin. So if you want to try this, and then pause this video, and when you're done, come back and we'll check answers. So if you want to do that, pause this video, I'll give a second, and then I'll start working it out. All right, well, welcome back. Here's another one centered at the origin. So 0, 0 is our center. Square root of 36 is 6. In which direction? In the x direction. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right. Square root of 4 is 2. So 2 up, 2 down. Lets me build the corners of my box. All right, this is a long, narrow one. Once you got your box, draw in your asymptotes. This one goes up 2 and to the left 5. So change in y over change in x. Y equals negative 2/5 x. What does the other one do? Well, that one also goes through the origin. So it goes up 2 into the right 5. So the other asymptote is y equals 2/5 x. Right? If it's an x squared, that means that it opens left and right. And so when we go to draw this, we'll make it open left and right. Right? Follow the asymptote down to the vertex, turn around, come down the other side. Come down, vertex, turn around. All right, you want the foci, add 36 plus 4, you'll get 40. So if c squared is 40, c is the square root of 40, which can be represented as 2 square root of 10. All right, so it's got to be inside there. So if we start at 0, 0, we're going to go 2 square root of 10 to the right. And then we're also going to do it to the left. So we're going to go 2 square root of 10 left and right, nothing up and down. So the square root of 40 is a little bit more than 6. So again, this thing comes pretty close on the inside here and there as my foci. If you want your vertices, then your vertices are just the corner of the place where that graph hits the box. So it's going to be 6, 0 over here, and then negative 6, 0 on the other side. Now, what happens if the hyperbola is not centered at the origin? Well, then it gets a little bit interesting because not so much that the graph is hard to graph, but sometimes the asymptotes are a little bit of a pain because they don't go through the center anymore. So let's do that one as a second video.